Hello, everybody. Welcome. Welcome to today's belated episode. I have been waiting to finish this project to drop this video, kind of with my opinion on it. But I finished the project today because I have decided I finished the project today. This grade will be a little bit lower than some of the other ones I've gotten, but that's part of the reason I'm okay with this. My grade is still an A, and I'm capable of getting an A at the end of the project, or end of the course, excuse me. And so, yeah, I'm letting it go because, as we'll talk about today, it's gotten pretty frustrating, to be honest with you. So I'm the Unhinged Engineer. Welcome to the channel. If this is your first time. I'm making professional development content for aerospace engineers, software engineers, people trying to work in deep tech and engineering, build their career as they go and are kind of learning things throughout the process. If that's who you are, then this is the channel for you because that's exactly where I am, right? And in addition to kind of learning things from the day-to-day, working full-time, I've also started going to grad school at night. So I'm studying computer science at Georgia Tech as part of a part-time online program with a focus in perception and robotics. And so, I've been vlogging my first class, which is AI techniques for robotics. So, right in the core of my specialization there. But yeah, so, we're going to talk about the search project today, which I believe is the fourth project of this course, and some of the ups and downs, right? So I will preface this, rant. I'm probably going to make the title, have rant in there somewhere, and this overall negative video with the caveat, or the disclaimer I should say, that I have really enjoyed this class. I have found it incredibly valuable. I think the instructors do a good job, and that has not changed since, doing this project. Granted, the last couple weeks have been a little miserable working on this, and juggling it with other things I have going on, but despite this project kind of being a low, both for me and for my opinion of the class, I do overall really enjoy it, and that hasn't changed. So that said, yeah, I really did not enjoy this project at all, and it was kind of reflected in the outcome there, right? So let's talk about it. So this project, the search project, effectively is all centered around like you are in a warehouse and you're moving throughout the warehouse. Trying to find boxes and bring them to a drop location. So you're doing robot delivery in this warehouse here. And there's three parts, A, B, and C. The first two are worth 40% each, and the last one's worth 20. And, it's that same overall kind of environment, that kind of setup, but some of the idiosyncrasies of each step, change from A to B to C, right? And for me, that meant implementing, multiple entirely different search algorithms over the course of the project. And I'll explain why. So also for context, I'll say, I'm very familiar with Dijkstra's at this point, and I'm very familiar with A-star. I've implemented them myself as part of personal projects. And the other one we're going to talk about today is value iteration, which I am less familiar with and remain unfamiliar after having done this project, right? So let's talk about these different methods and whatnot. So for part A, it was a lot more about edge cases, which at first was a little frustrating, but I honestly really enjoyed because I had to implement my naive understanding of A-star, and then there were lots of wrenches thrown in, right? Lots of different weird edge cases, like where you don't return a path, or there is no path because the destination's right next to the goal. Like weird things that, when I built my personal project, I didn't bother with, right? Because it was, trying to just learn A-star the first time. And those were good. I think those pushed my understanding very well. And despite, honestly, me spending the most time on part A, I did enjoy it, right? I think that was good. Despite drawbacks that were, overall, ubiquitous in the whole project. And I'll talk about those soon. But the other one, part B, you no longer, let me rephrase this. At that point, you have more access to warehouse information. Like you can kind of loop over the grid, which in the first part you couldn't. You were only allowed to know kind of like what's around you, right? And the general location of the box without knowing a set path. That's what A-star's for. But now you have more observability, like you can see the entire grid. And so, you have to search for each grid, you have to have a policy that causes the optimal least cost to action, right? So every square now has a cost associated with it. I think they say the floor is slanted or something, it doesn't really matter. Each square has a cost associated with it, and then like the wall has, infinite cost, or however you define that, and the box at 0 cost, because that's where we're trying to go. And so, every square grid of your grid-based policy should drive you towards that box that you're trying to get, right? Or drive you back to the drop zone if you've picked it up already. And so, at that point, like I just said, I used Dijkstra's. That part also went fine. It was a little less heavy on the edge cases, but still enough that I feel like it was substantive, which was good. And then there's part C, which, I'll tell you right now, I'm getting an 80 on this project, right? So 40% was from part A, 40% is from part B, and 0 is from part C, okay? And I will preface this by saying, I had to implement value iteration for this part. And the reason is because part C introduces stochastic motion. So now when our policy says to do something, we no longer know for certain that we're going to do that. We might do something, move off to the left or to the right or whatever else. They have this like weird slanted motion model, which is a little strange, but straightforward enough. And now we have the stochastic motion, and it was possible for me to kind of like jerry-rig my Dijkstra's to account for that. I tried that several times. I think my final submission with kind of like spaghetti code that doesn't even work had Dijkstra's in there, right? But then previous submissions also had value iteration. Now, value iteration, I was not familiar with prior to this class. And I have to be frank here, where I'll say this was the first time I think in the lectures that the lectures really failed me here, right? I mean, for every project, it's pushed your understanding beyond what the lectures talked about. That's not new. If you go back to even like my particle or Kalman filter reviews, like I enjoyed that it pushed the concepts further, be it through edge cases like with A-star or with, what was it called? Oh my God. Fuzzing. Thank you. Sorry. I might edit out that pause or not. I don't know. Fuzzing in the particle filter. Like pushing those concepts further was really great. But this one, it just like the lectures were complete with. It was so simple. Like they never drew a grid beyond like a 3x3 grid with a Sharpie. Like, the code we wrote was so simple. And by the way, I'll get to the runner in a minute, but just so simplistic and like unrepresentative of what we actually had to do, at least in my opinion. I could be wrong. There are obviously students who are going to get 100 on this project, and they must have understood it much better than me, but I did not. And so, I tried value iteration a few times. I tried, fixing my Dijkstra's to account for stochastic motion a few times, and I was still getting 0, 0, 0, 0, 0. And this brings me to my, biggest complaint, I think, with this project, okay? Part A and B, forced you to just come up with an algorithm that's as good as possible, right? Like your performance, how close to optimal and how few, faulty moves your algorithm makes is what determines how well you're scored, like how good your grade is, right? And I like that framework, right? Because now, it's up to me to design an algorithm that performs adequately for whatever grade I'm trying to get, right? And for me, it was 100 on each. I felt like that was a fair way of grading things. And I really hate throwing fair around because life is not fair. And there's lots of copium about this project's not fair, right? But, part C changes that paradigm from you need to create an algorithm that performs well to you need to produce the exact same set of outcomes that we do for every step of your trajectory from, the starting position to the box. So I would really appreciate if anyone can explain this to me. I don't go and like edX and rants to professors. It's just, to me, it's unprofessional. I mean, if I'm asked for my feedback, I will give it, but I'm not going to go and roast some, unsuspecting TA, right? Someone please explain to me why you decide that after you add stochasticity to your process, you change the grading criteria from adequate performance to exactness. That makes no sense to me. It would have made more sense if, you had to implement Dijkstra's with deterministic motion, or even A-star, but they could have specified what heuristic to use. They wanted you to pick the heuristic, which again, I think is a good thing, but let's assume an alternative version of the project. You could say for Dijkstra's and A-star, which are both deterministic in this way, we want you to give the exact same action for every square, right? That would have been fair, because Dijkstra's finds the optimal solution. And then once you introduce, I think there's a train outside. Then once you introduce randomness, right? Then you can say, okay, we're gonna loosen the requirements, and now if it performs within some percentage of efficiency compared to the optimal one, we'll give you, points, right? That makes way more sense to me than introducing randomness into the process and then expecting an exact, match. An exact match, not even of the policy, by the way, but of the outcomes, right? And it stopped making sense to me, to put bluntly. It really stopped making sense to me. It was very frustrating. Someday I will return to value iteration and I will implement it on my own in a much less frustrating and time-constrained environment. And hopefully I understand it then. But up to now, the lectures were insufficient in my opinion. And, that grading criteria was just brutal, right? And I've alluded to this a few times, but I have some other things going on in my personal life that have just made devoting more time to this project, not in the cards for me, right? And so, yeah, I'm gonna get an 80. I still have an A. I still can get an A. I honestly already feel more relieved now that I'm talking to you about it and have let it go. So I think it was the right decision. But before I move on, some other ranting. I think one big weakness of, honestly, this course, but more specifically the projects, has been the runners that we're given. Like, the software engineering of these runners is ridiculous to me. I have always been against, tasking a software engineer, a person we're trying to teach coding, like giving them one function within which to implement everything. Because that's not how the real world works, right? And I appreciate them giving us the visualizer and all these peripherals, like doing them, for us. Like, obviously that's important and I'm grateful they do it. But the structure is just like really weird. Like, why not just define an API that we could use, right? Like an API for the visualizer or for the test case runner or whatever else that we can just, hook into directly, right? Instead of, we've got all these peripherals that we have to download to our computer because, they don't use GitHub for some reason. I don't know why. Download to our computer and then, it pulls in all these different files that we can't see and are weirdly organized, right? And all of our work is confined to one function in one file, right? In their defense, it does use like, class structure that you can add other methods to. So it's a little more sophisticated than I'm letting on. I mean, I remember when I was in high school, we had to use this thing called Zybooks. If you have the misfortune of knowing what that is, I pray for you, because I do. And that literally was editing single lines of a function to try to demonstrate like software engineering, which is hilariously dumb, or computer science at that point. But, to me, I just think the way they set up the runners, and then also too, like some of the decisions they make, like for each motion of the policy, the output was a string. So like move south, move east, down south if you're dropping the box to your, the square below you, right? Lift 1 if you're lifting box 1, like literal strings, string literals. And that is so annoying. That was so annoying to work with. Why would you do that? Why would you not just define your path as the set of squares that you walk on in the grid? Like everyone has, we're all time. Like that, everything in my code was a dictionary. Literally everything was a dictionary of strings, and it was egregiously annoying to work with, right? And I probably could have, designed that in some better way. There's always room to take responsibility, and I don't want to blame the instructors. Like I said in the beginning of this, I still think it's a good class. I just did not enjoy the search project at all, and I'm not going to get a good grade on it. But that's a decision that I've made. I'm a big boy. It is what it is. Okay. I guess overall, I should give it a ranking because I have given the other projects ranking. I don't remember what I gave the other projects, but I would probably give this project like a 4 maybe a 5. It really was just part C, in case you can't tell, that drove me up a wall. And like I said, there were some decisions that, I made that kind of shot me in the leg. For example, using Dijkstra's all the way up until part C, when I should have had the foresight to think, oh, Dijkstra's, assumes deterministic motion, and it's going to be a whole lot more complicated to kind of retrofit Dijkstra's to work with the stochastic motion model. I should have thought about that. I didn't. That's on me. I'm sure some of those dictionaries I could have made simpler. That's on me too. It is what it is. But I would probably rate this project like a 5 out of 10, maybe a 4. A couple of days ago I would rank it a 4 when I was still at war with it. But let's talk about the rest of the class here, right? So after this, there's really 2 assignments left. One is the SLAM project. In addition to that, there's SLAM lectures. And then the other one's the final, right? So I believe after getting this 80 or 78 or whatever it was, I will have a 92. Before that, a 95, unfortunately. I'll have a 92, which is still an A. Their grading system seems strange. I can talk about that in another video. So yeah, I just gotta make sure I really crush the SLAM project and do well in the final. I believe the final is formatted very similarly to our midterm. It just has more material and it's worth 50% more. And the SLAM project, I don't really know anything about. To be honest, I watched the SLAM lectures, but didn't really pay attention that much. I just kind of tried to get through the homeworks because, I've been working on other things lately a lot. That should be, abating soon, hopefully, hopefully with positive outcomes. But yeah, I'm going to take this break. I'm going to lick my wounds. I'm going to focus on the other stuff I'm doing, which is almost come to an end. And then, once it is over, I really want to take a step back and I want to really soak in the SLAM lectures, because SLAM is something I have wanted to learn for a very long time. Dijkstra's an A-star, fine. I feel like I know it. I still feel like I know it, even after having not done well in this project. But I could just be coping. Who knows? But like Kalman filters are something I really wanted to learn. Particle filters were not something that I really thought about going into this, but the second I got into that project, which I feel like was really well designed, so well designed I put it on my portfolio. In fact, I realized it was valuable. PID control I'm very familiar with. That's fine. And this one, is what it is. Every search algorithm, it's such a circumstantial thing. It's going to change a lot. But SLAM, which is also circumstantial, but it's okay. SLAM is something that I've been dying to learn in a classroom setting for the longest time. And in aerospace, it's more of a robotics thing, right? Which is part of why I'm studying robotics now. In aerospace, it's less commonly discussed. I don't really know why, but it just hasn't broken into that space yet, at least in my experience. I'm sure there are aerospace engineers out there who have used it. But I'm so excited to learn about this. So I'm going to take a hard reset, make the most of this, break I've afforded myself by sacrificing some points on my grade. And just get back into it. So yeah, normally this is where I do my outro. With thanks so much for watching. Please like, comment, subscribe. But if you watched this far, I would assume, you're a subscriber. And I just want to say I appreciate y'all sticking with me. My uploads have been more consistent. I am just as unhappy about it as any one of you are. I really have enjoyed working on this channel, and life has gotten in the way. I cannot share why yet. I'm really hoping at some point, it pays off and I can. So yeah, I've just been working on this stuff and I've been a little less consistent than I'd like. But that will change soon, very soon. We are almost around the corner. So if this is the type of content that you're interested in and you've stuck with me this long, I could not be more grateful, and I beg of you, I implore you to stick around, because there's great stuff on the horizon. So thank you so much for watching. I've lived up to my name once again. I am the Unhinged Engineer. And I will see you in the next video.